All right, our goal today is going to be to identify the start value and our factor of change in an exponential equation, table, and scenarios. So the key here is going to be to realize what these variables mean. So A, or that value outside the parentheses, is going to represent our initial value, while B, the number in parentheses, is going to be our base or our rate of change. So that tells us how fast we're increasing or decreasing. So if our B, or that number inside the parentheses, is greater than 1, that's going to indicate that we have some growth, okay? Because we're multiplying it by a whole number. If it is between 0 and 1, so if it's a fraction or a decimal, that's going to indicate that we're decaying or decreasing. Because if you multiply something by a fraction or a decimal, it's going to decrease. So let's look at number 1. So A, my initial value, that first number is 3. Inside the parentheses is 4, and that's a whole number. It's greater than 1, so it's going to be growth. Number 2, the number in parentheses is 1/2, so B is 1/2. That means it's decay, and our initial value is -3. Number 3, 0.25, that's a decimal, that's between 0 and 1, so that's decay. Our base is 0.25, and our initial value is -2. We're going to keep going, so the next one, 3 is greater than 1, so our base is 3, it's growth, and our initial value is -5. We'll keep on going. In the parentheses is 2, that means it's growth, it's greater than 1, and our initial value is 1/2, because that is outside the parentheses. This one is a little bit tricky, so if you notice, there are no parentheses, okay? We just have a number raised to the x. So that number raised to the x is still going to be our base. Whatever number is raised to the x is our base. So B is going to be 1/3. That means it's decay, okay? But we don't see a number outside parentheses. So if I were to draw those in, we know that there's going to be an imaginary 1 outside of those parentheses. So our initial value is 1. Number 7, number in parentheses is 5/4. Now if you notice, this is 5/4. So if I had 5 quarters, okay, that would be over $1. So that would be, if I had 4 quarters, that would be $1. If I had 5 quarters, that would be $1.25. So this is actually 2 times 1.25 raised to the x. So if the numerator is bigger than the denominator, the number is greater than 1. So that's growth, because it's greater than 1, and our initial is 2. Number 8, that number in parentheses is 5, so it's growth, and our initial is 8. All right, moving on to tables. So we want to identify, is it growth or decay? What is our rate of change? What is the y-intercept, and what's the equation? So this one, if you notice, we're going from 600 to 300 to 150 to 75. So that's definitely going to be decay, okay? And if you notice, we are multiplying by 1/2 each time because we're dividing by 2. I don't know what just happened. I X'd out, sorry there. So we're dividing by 2 each time, okay? Which is the same thing as multiplying by 1/2, okay? So my B is going to be 1/2, this is decay, and then our y-intercept, our initial value, is always going to be where x equals 0, okay, just like in linear functions, so that's going to be 75. So if we put that into an equation, our initial goes on the outside, so it would be y equals 75 times 1/2 raised to the x. Our next one, notice we're increasing, so we multiply by 5 every time. Okay, so that's growth. Our rate of increase is 5. X equals 0 when y is 100, so that's our y-intercept. So our equation is y equals 100 times 5 to the x. Our next one, we're multiplying by 10. so our base is 10. Our y-intercept, we have to work backwards to figure out where x is 0. Okay, so instead of multiplying by 10, I'm going to divide by 10. So 10 divided by 10 is 1. Our y-intercept is 1. So our equation is y equals 1 times 10 to the x. And you could also just write that as 10 to the x. That's the same thing. All right, next we've got this one, number 4. So we are multiplying by 4 every time. So our growth rate is 4. Our y-intercept happens where x is 0, so it's 1/4. And our equation would be y equals our initial value times the base raised to the x. Number 5, we are dividing by 2, which is the same thing. We always want it in terms of multiplication, so multiplying by 1/2. So that base is 1/2. Our y-intercept happens where x is 0, so it's 32. And the equation is y equals 1/2 times, our initial goes first. It's a times b to the x. So 32 times 1/2 to the x. In our last table, we are dividing by 5, okay? But we always want it in terms of multiplication, so that means we're multiplying by 1/5 each time. So that's our base. Our y-intercept happens where x is 0, so we're going to have to continue this pattern. Instead of working backwards, we're going to work forwards. So I'm going to multiply by 1/5 again. So 20 divided by 5 is 4. So our equation would be y equals 4 times 1/5 to the x. All right, a couple more, guys. We're going to look at some situations. So Allison has $40, so her initial money is $40, and she spends half of the money she has in her savings account each month. So she's spending money, so we're going to decay, we're going to lose money. She spends half of it each month, so we're dividing by 2. So our equation would be y equals 40 times 1/2 to the x. Number 2 says Janet owns 5 restaurants. Each year her ownership triples. So we're tripling, so we're growing, we're increasing. She starts with 5, so her initial is 5, and we triple. So our rate of increase is 3. So our equation would be y equals 5 times 3 to the x. Number 3, Jessie bought 2 rabbits. Every month the rabbits reproduce and double the amount of rabbits. So we start with 2, we are doubling, so that's growth, and it's a growth rate of 2. So our equation is y equals 2 times 2 to the x. Jacobs High School currently has 2,259 students. The student population is dropping by a quarter each year. So we're dropping, so that's decay. We start with 2,259, and we're dropping by a quarter. So our rate of decrease, or rate of decay, is 1/4. So that would be 2,259 times 1/4 to the x. 2 more. You purchase a car for $15,700. So we started at $15,700, and the car depreciates by 1/10 each year. So it loses value. So we're decaying by 1/10 each year. So our rate of decay is 1/10. Our equation would be 15,700 times 1/10 to the x. And last one, a ball was dropped from a 60-foot building. So we started at 60 feet. It was dropped, so we're decaying, and it bounces back to 1/3 of its height. So our rate is 1/3. So our equation would be 60 times 1/3 to the x.